Thanks, Shruti. Hey, everyone. I am one of the tech leads in AI Center of Excellence team managing the APAC region. So today I'll be walking you through. LangChain and LangGraph. There are two notebooks which will be shared after this meeting or during the meeting. So what it is like. So briefly, I'll walk you through what LangChain and LangGraph is, uh, and then we'll see how to use that to build a multi-agent system. This is just an overview. I mean, you can build very complex applications with LangChain and LangGraph. So just to give you a flavor of what it is, I'll be walking you through these notebooks. So let's dive in. As you can see, like LangChain and LangGraph, you must have heard or you must have gone through the site website. So it's a multi-agent framework which is very popular, and most of the other multi-agent frameworks which you will come across like SmolAgents, Crew AI or Pydantic or Haystack, or there are many others which are coming in the market. So you will see that they are very similar to LangChain and LangGraph, and so what they are doing is basically taking the concept of LangChain and LangGraph and they're building it in their own way, just by adding few features and here and there. So you'll see a lot of similarity uh, between the frameworks, but all of them can be used to build multi-agent systems and everything. So let's dive in. Like first and foremost, like to install the package, which will do that. Like if you see here, I'm using Google API key for doing this, but you can use any other API key like OpenAI, Mistral, Grok, or any other things, whichever freely is available. Like Google API key I'm using here is free one. And I'm using this environment which is called the Google Colab. Google Colab is nothing but a cloud environment where you can go and run your codes. It's very I mean, if you are familiar with VS Code and every other thing, so it's just one other IDE, like, but it is based on cloud and it provides very good runtime. Like if you don't have a very powerful system to run some of these codes and algorithms and build agentic system which require very high compute systems because of the processing power needed to process the LLM and everything. So you can use these Google Cloud, cloud environments, which will provide enough GPU, CPU, and RAM for your experiments. So as you can see, I'll go walk you through. So LangChain and LangGraph, LangGraph is it's the framework which is used to build the agent, and LangChain is the overall framework. So as you can see here, LangChain and LangGraph is, so as you can see from the name, it's graph. So which means that at the end of the day, when you visualize it, like I'll show you here, when you visualize it, it will look like a graph. If I come down here at the end, see, you'll see something like this, like in a graphical manner. So there are nodes which are like the agents and everything. And then, yeah, so as you can see, this is a supervisor agent. This is how each of the agents are connected. So it's basically a graphical nature. Like if you go in depth into the framework. Now, as you can see, you have to define. First, you have to define. So first step, you have to install the packages like LangChain, Google. Since I'm using Google API key, so I have to use the Google Chain AI and then LangGraph. And for OpenAI, there will be separate OpenAI and everything. So for each provider, there are, so you have to install that particular provider's package so that it gets connected to that particular provider API key and the systems. And here, from here, you have to import the necessary libraries and everything. And from LangGraph, you have to do state graph, which is basically that graph which I have shown you, and then the start and the end date. And then you have to define the graph state. Now, state is a crucial. It defines the information that is passed between the nodes in your graph. So that's the graph. I mean, you have to define this graph state, and then you have to define it in this way, like represent the state of our graph, and then what it will do, and then you have to call the LLM nodes in, and then you have to pass the graph state here, and then you have to define something called as workflow. Workflow means the step-by-step execution process. So workflow equal to state graph, and then you have to add the LLM responder, and then you have to set the entry point of the LLM. So entry point of the graph and the exit point of the graph. and then you have to compile it, and then so I'm just giving a message saying that the running the LangGraph application with a simple greeting like hello, how are you doing, like that. So it's anything you can give. It's not like that. So as you can see, like the package has been installed. And the other advantage of Google Colab is that there are many Python packages which come pre-installed with this environment. So you don't have to install it separately. Most of the things will be pre-installed. And so Google keep on updating these features of Google Colab. Google Colab has free version, pro version, and this premium version. So I'm using the free one. But if you use pro and premium version, you'll get access to a lot more GPU powers and everything. So as you can see, LLM responder, hello, I'm doing great. Thank you for asking. As I'm an AI, I don't have experience filling days and everything. So it will just give a generic message. And then the capital of France is, so this is just to check if how the each of the states are working with the LangGraph. This is a very basic example of a LangGraph, like with one agent and everything. But if you are going to do a multi-agent, like this is one of the examples. Like I'm just doing the same thing as I did earlier. Like this is the very first step which you have to do, like import the libraries, define the state graph and the start and the end, and then do all this human message, base message, AI message, import the key and also, and here you have to just define the model that you will be using. Since I'm using Gemini, since I'm using Google API key, I'm using Gemini 2.5 Plus. So for OpenAI, you have to give the appropriate model here. So for each of the providers, you can just give whichever model is appropriate. Because this we are defining here a multi-agentic framework. So you have to do a multi-agent state graph. In the first example, we saw a single agent state graph, like very basic example, but here multi-agent. So same thing, list of messages and conversation as we defined above. Then we are defining the agent nodes. So each of the nodes, so there'll be, so here we'll be doing two agents. One is a researcher agent, another is a writer agent. So what they do, so researcher agent will simulate the research agent. It takes a query and generates some research nodes. And what the writer node will do, so writer agent will take this research nodes and synthesize into a final answer. And how do we define? So first, we have to define the state query, then simulate research by taking LLM to provide some relevant points. So this is a research prompt. As you can see, so provide some key facts or point related to the following topic. Keep it concise for a research note. And for the writer agent, we'll have a similar thing. Based on the following research note, write a concise answer to the question like this. So we'll come to that. Since here I've given query, so this part is variable, which means that any question we can ask. And then we have to define something called a router. Router means what router will do. Suppose it doesn't, I mean, if you have experience with if else and all, so whenever we write a program, we have to define the edge case. Edge case scenario means suppose the program hits some unknown state which it doesn't know how to process, like some empty variable or zero or empty state or something like that. Then you have to define what the programming is expected to do. So here also you have to define, like if the research node is empty, then go to the research agent. If research node does not exist, if research node exists but no final answer, we have to go to the writer agent. If final answer exists, we have to end the graph. So these are the three scenarios which you have to define based on how you are building your agent. It is very important to define this kind of scenarios where the, suppose you don't have any answer, then what the program or the agent is supposed to do. It is, so you have to define these kind of scenarios. And then if not state research nodes, then no research, go to research agent, and then I just whatever it have written here, I've just written it in a programmatic way. If there is final answer and state is research nodes, research but no final answer, go to the writer agent, and if there is a final answer, you have to end it. Okay, let me run one by one. See, these are functions. You won't see any output until I go to the point where it is taking all the things and executing it. So here is the step where everything is getting processed. So building the LangGraph multi-agent workflow. So you have to define this. This is how you define it. first you have to do the state graph, multi-agent state graph, and then you have to define the node, add node, recharge agent, and then the writer agent, and then all the conditions, and then you have to do end. And then you have to any conditional edges, like since it's a graph, you have to define the edges and the nodes and everything. So that's how you add this
Um, uh,
conditional edges. Yeah. Hello. Any
Sheila
question?
is asking, can you explain what is state and what does it do?
State means like what is so your current state. So I mean, in order to give some analogy, like what is your current state? You are just listening to the lecture here, like so you are in a listening state. So state means the state in which the agent is currently in. Like you have to define that state, for example. So right now nothing is defined. It's just empty. It's the agent is getting defined, but I haven't executed the program yet. So once I execute the program, the agent, the states, all is getting defined. So state means what the um agent is in at present. So you're just an empty. So right now, if I go here, agent here is getting defined here. That means right now, if I print this, nothing will be there because I haven't executed or I haven't called the agent, and all the agents are in kind of a sleep state. I mean, you can think of that because I haven't called them for any query. Since I'm the user, when I'm calling the agent, then only the agent will start executing my um, question or the prompt that I'll be giving. So that's the state. So sleep state, wake state, like that. You can imagine it. So sleep and wake state are physical states in an agent, like in an AI. If you read about it, like there's a sleeping state, there's a waking state, like that. And then, so it's called a wake sleep algorithm is there, but I mean, it's not the scope of this talk, but state you can think of in this way.
Got it. It means that we can say that once we initiate the command, at that
Correct,
time it's shifted to sleep mode to awake mode.
correct. Right now,
The state
since,
is changed.
yes, so
Mhm.
right now I'm just defining the agent. So right now there is no agent. I mean, if I
Mhm.
plot, we'll see an empty everything because I haven't called or I haven't told the agent what to do. It's just sleeping. It's nothing for it to process. So moment I'll execute this program, this one, you'll see at the end that it will generate output. That means that I'm calling the agent is processing the input and then is producing the output,
Mhm.
like that.
Great, great. Sheila is saying thank you for the clarification. Understood very
Sure,
well.
no, yeah, no worries. Yeah, so as you can see, you have to define everything after the agent writer agent complete the router decides the next step. As you can see that's why it's very important to define the router and define what the agent is supposed to do, like right from the input, the output, and what it is supposed to process. So these are the three things is very crucial for any agentic system. So you have to define the agent, or else what LLM or the agent will do, it will think on its own and it will just generate something. So running the multi-agent query. So now I am initializing. Now it is running, as you can see here.
Mhm.
Uh, let's see. As you can see, routing, no research node, go to the research agent, then a research agent output. Here are the main application of quantum computing medicine. Now, now routing, research nodes exist, but no final answer. Go to the writer agent, writer, and then, so remember, I mean, I defined the routing part. Here it is. So here, if you go through this output, you'll know what the router is doing. Now, routing, final answer complete, end. It has found the answer. Now, again, final result. So remember, there was a final result which I defined there. Means that once the agent gets the final result, then only it will end. So unless it finds that, it will keep on executing. Final answer complete, end. What are the main applications going to medicine? Final answer, main application is here. LangGraph tutorial. So as you can go through this, it is supported to research agent. there's a supervisor agent, there's an agent 1, agent 2, agent 3, and they have tools. And then the supervisor agent basically decides, like based on what the user asked, which agent to process. Like it can happen that they have to process one after the other. So the supervisor agent will decide that. And supervisor agent will give the final response to the user. So all the agents will give the response to the supervisor agent, and supervisor agent will give the final response to the user. Now first let me, as you can see, like first is setting up the environment. Okay, I have to. So first is setting up the environment, and then once the environment is set up, then we'll set up the API keys. Yeah. So Tavily is a, you can go through it. Like Tavily is a tool which provides the AI agents to surf the internet to provide the answer. I mean, for any other anything. So it's very good. It's a very, like the agent and AI will use the Tavily search to search for relevant contents in the internet. So I've just given the keys. Here I'm just calling the model, all the things. So these are like the environment setup, which you have to do before running anything. Like even if you are building an application, there will be an environment variable where you have to define all these things, and everything that has to come as a prerequisite setup to for AI to execute in that environment. You have to set up the environment first. Done. Now I'm creating the tools Tavily. This is the web search tool that Tavily search as a. So Tavily, as I said, there is a web search tool which the AI uses to surf the internet to get some anything. Now I'm here. What I'm doing is agentic RAG. Like I'll show you once it's loads. So here it will create a folder called docs, and there it will expect some document. So once the folder is created, I'll upload one document. We'll see. See, this is the folder. What I'll do is I'll upload something there. If I run it now, it will say something has done. Yeah. Now then what I'm doing here is chunking. Chunking means splitting the documents into small sub documents, like for it to execute perfectly into 14 chunks. Like chunking is an important step, because if you give a huge amount of document to the LLM won't process everything at once, because in that case then the compute power and the processing power will go high and system won't be able to handle it. So what we do is basically we'll chunk it, and this is also an efficient way for the LLM also to process the data. So instead of processing one big huge document, it will process multiple small documents, and it is very easy for LLM to query and to similarity search and all these things. So it's very easy to vectorize and very easy to search also. Just increasing the efficiency of the LLM and the way it is processing the information. And then it will generate embeddings. Uh, Embeddings are like vectors. So LLMs and machine learning, deep learning, any algorithm, they can't understand text. So it has to be numeric. So hence what we do in NLP, there is a concept called TF-IDF, term frequency, inverse document frequency, meaning that all the all the text that you see will be converted into vectors, and it will be stored as an embeddings in the vector databases. So here we'll be using Chroma. I'll show you. So this is the algorithm for sentence transformer embedding. So it will take all the words in the document, it will convert it into a numeric embedding format for LLM to understand. So just creating a collection. So as I said, like this is the vector store. ChromaDB is a very popular vector database where we'll store all these embeddings there. And then we'll be using a retriever tool for the model to get the embedding based on the user questions. And then this is a document ID total for this is the entire document which is there. Now I'm creating, so this idea here is called a Chinook database. Chinook is a very popular database for training. It's an SQLite database. You can go through it. What we'll do as a part of this exercise is basically talk with the database, like, to write queries like SQL queries, select star, this, from, this, where, some condition with it. What if you can just talk to the database saying that, okay, give me, in a natural language, you will ask, and the agent will fetch the results for you. So instead of writing SQL queries, you just have to talk to the database like in a natural language, like how many employees are there in the table, like what are the ages of the employees, how many employees are there, what are their names, list, all this. So you're just writing it, you're not writing a query, just simple natural language.
That's pretty interesting, Tamal.
Yeah. So this is what, like, okay, let me, yeah. This clean SQL query block, like it will just take the query. So I'm just writing the query in a way that you don't have to write, but but the agent will fetch all these things. Internally, it will process like this, and then it will give you the result. So agent is processing that SQL query, and it is just giving you the final result. So instead of you writing the SQL queries, agent is doing that part. You just ask the agent, like, I want to know this. Agent will take that, process it, give you the output. That's it. And for defining some of the blocks, so you have to write like this, like in a regex format here, and keyword select star from where. So all the SQL, so it will process, it will take all these things as input, it will create the SQL query. Internally it will create all these things, like it will understand the user needs, and then it will create this, and then it will give.
Great, great. So, Tamal, if there is,
Yeah.
suppose, if there is not any very unique query which is not you have used here, so how then they will put it?
Unique queries.
I mean, this is a simple query, how many employees are there? But if we wanted
So
to know which employees in
yeah.
which department, that kind of query. So how they will,
So it all, yeah, so it will be, so these things is part of the data that will be there. So it's a Chinook database. I mean, the database, so all these are functions of the database, like in the sense the data that you are asking has to be there. If not, then it will throw a, it will say that I can't process this information is not there. Suppose if there is no column, if there's a particular concept, say for example, you want to know the salary of some person, but the salary column itself doesn't exist in the database. Then the agent will say this, I mean, mismatch or some error, it will say that this column can't be found. So whatever you are going to ask, if the data is present there, the agent will fetch and give you. If the data itself is not there, then it won't be able to process it.
okay. So any kind of data is present, it means either you write down a query or not, but the question, based on the question, if data is present, they will give you the answer.
Correct. See, here I'm just asking how many employees are there. See, user, how,
I request all the participants, it's very interesting in SQL how you are using this query and how you are getting this from the data. That's pretty interesting. See the output, how Tamal has run, how many employees are there, and see now it is running the command by itself. You are just saying in a layman language how many employees are there. No need to write any code and something.
correct, correct. So this is
Mhm.
a very typical example, it's called text-to-SQL. I'll just say for the,
So
oops,
this is here you are using which tool, AI tool basically, Tamal?
oh, exit, exit, goodbye. Huh. It was pleasure assisting. If you have more questions in future, feel free to reach out something it will give. Yes,
Okay.
correct. Yeah, so I wrote this entire thing in LangGraph, but
Mhm.
I'm using a tool, NL2SQL, as you can see here, like NL2SQL tools. So tools are nothing but connectors. The agent, say agent, if an agent has to, see agent doesn't have internally the database, so it has to connect to the database to get the answer for you. So in order to connect the agent to the database, it needs some connectors. In our case, I'm using a tool called NL2SQL. NL means natural language to SQL. That
Got
means
it.
that whatever you are asking is the natural language here, like how many employees are there. It is invoking the NL to SQL tool and it is giving you the answer. NL to SQL tool will process in between. As I say, somewhere I just define this one, right? See, inside NL to SQL, it will, what it will do, it will just
Mhm.
ask the query. Like all this processing will be done internally. You don't have to. So this processing that you see here, right? I have written so many things here, like regex pattern and all this select and all everything. So the tool is invoking all these things. It is understanding what kind of database it is going to connect to, and then it will judge it. So these are the universal SQL syntaxes, like selects from, group by, having, order by, join, everything, and then it will fetch based on the answer. It will just fetch the answers, like based on the user questions and all everything.
Mhm.
So
Uh,
if I run this, as you can see, like agent, as I said, in this is how it looks like. If state graphs and system, so it will just something. It will be, yeah, yeah. Feel free to ask. Yep.
And the important question, which is very interesting, Aditya is asking how to make sure the agent does not generate SQL update or delete query, like you are using a NL tool to shift to the SQL coding.
Correct.
So maybe the layman language, they will update the data, delete the query. So how to involve that human in the loop workflow?
Yes, very good. So here I haven't shown that, but there is another step which you can do, like the human in the loop concept. Human in the loop concept, what it will do is basically, you don't allow the agent to execute on its own. Moment it gets it gets a response or it gets a question, the user has to approve those responses. Like say for example, if I ask how many employees are there, the agent should verify saying the user is asking this question, approve or reject, like this. So this is one way, and then moment the agent, the user approves, then only the agent will process, or else it will not process. So that extra layer of check, the human, you can add it. I haven't shown it here, but that's one step which you can add, which will make sure that the agent does not do anything accidentally or in its own way, imagining and all everything, hallucinating and all these things. So that is one way which you can maintain control, like by introducing user approval or rejection.
Great. Thank you so much, Tamal. It was really a very engaging session and very awesome session. A heartfelt thank you, Tamal, for the clarity, simplicity, and confidence you brought to today's session. Your guidance
Yeah.
made complex ideas approachable and empowering. To our amazing audience, thank you for learning with us. We hope you enjoyed today's journey as much as we did. See you tomorrow.